All right, let's look at this example on how we graph rational functions that have unique factors. So I have my f of x. There are no common factors that cancel out. So we can go ahead and find the x-intercept. To find the x-intercept, set the numerator equal to 0, and we find out that we have x equal to 2 and x equal to negative 1. So the x-intercept are these two. And then we have the y-intercept to find. You set x equal to 0, solve for it, we end up getting 2 over 3. So the y-intercept is 0, 2/3. Now the next thing to find is to look for the horizontal asymptote. And to do this, we need to rely on the 3 ways that we discussed in the other video on how to find horizontal asymptote. Meaning if the degrees are equal, then we just take the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. If the degree of the numerator is smaller than the degree of the denominator, then we have y equal to 0 as the horizontal asymptote. And finally, if the degree of the numerator is bigger than the degree of the denominator, then there was no horizontal asymptote. So in our problem over here, what we had to do was expand the factored form of that function, and we can see that the degree for the numerator and degree for the denominator are exactly the same. So we pick the coefficient, their leading coefficient, and we end up getting a horizontal asymptote at y equal to 1. To find vertical asymptote, you look to the denominator, set it equal to 0, find the factors that make that rational expression go to 0. And in our case over here, we found 2 of them. So we get vertical asymptote at x equal to negative 3 and x equal to 1. We have all the ingredients we need to kind of put a sketch together now. So if you put in your horizontal asymptote, y equal to 1, you put in your vertical asymptote, y, x equal to 1 and x equals to negative 3. You locate your x and your y-intercept. We're good to go. The only thing we do not know is if I look at the horizontal asymptote, I'm not too sure if it's going to be below the line or above the line. Not too sure. And then if I look at the vertical asymptote, I'm not sure if it's going to positive infinity for x equal to 1 or negative infinity. And for the other vertical asymptote, I'm not too sure if it's going to positive infinity or negative infinity. So we're going to rely on our analysis, our vertical analysis to help us. So let's look at that chart real quick. When you look at the vertical analysis, I'm analyzing what happens when I get close to negative 3 from the right, negative 3 from the left, 1 from the right, and 1 from the left. So your job is to pick some numbers that are really, really close to those asymptotes. So if we look at the first one, if I pick from the right, if I pick negative 2.999 and I plug it into each of the factored expression of the function, I get these signs, negative, negative, divided by positive, negative. We end up getting a negative, so we know that for that problem, we are going to, for that, as we approach negative 3 from the right, we get closer to negative infinity. So you do the same thing for negative 3 from the left. If you pick, say, negative 3.001 and you do the sign analysis, you see that the graph approaches positive infinity. Similarly, if you do 1 plus, say, 0.999, you do the sign analysis, you end up with negative infinity. And then lastly, if you do 1.00, oh, I think I flipped it. If it's 1 plus, you're going to use 1.001, and that gives us negative infinity. And if I use negative 1 from the left, so that's going to be 0.99, then you end up with a what? With a positive infinity. So with this information, now I am certain that coming from 1 from the right, it's going to negative infinity, so I don't need this. And then coming from the left is going to positive infinity, so I don't need that. And then if I look at negative 3 from the right, it says I'm negative infinity, so I don't need this. And then negative 3 from the left, I am going to positive infinity, so I don't need that. Lastly, we need to kind of analyze what's going on with the horizontal asymptote. Am I getting above or below that line? So all you need to do is just plug in some value. So if I look at the right side of that graph, I pick x equal to 4 and I plug it in. I end up getting 10 over 21, which is under 1. So I know that now the graph is below y equal to 1. And then if I pick up x equal to negative 5 for the other side, for the left side of that graph, I can see that when I plug in negative 5 in, I end up getting a number that is bigger than 1. So I know that the graph would have to be above the line y equal to 1. So we do have a roadmap to sketching this function here. So it looks like it goes through there, and then it goes through there. We can see that this goes through here, passing through the x-intercept, the y-intercept, and then trying to get closer and closer to the vertical line. And then I have the last piece to put together. So that becomes the graph of that function. Alrighty. So that's the end of the problem. I hope this makes things clearer for you. See you later.